Hi, I'm Dr. Ward. In the last video, we looked at some of the fundamental math concepts behind dimensional analysis. Now in this video, we're going to take a look at applying those concepts to solving simple 1 and 2 step dimensional analysis problems. When I say simple, I don't necessarily mean easy, so if you don't get it right away, that's not a problem. When I say simple, I mean 1 and 2 step conversions involve units that have very common factors. There aren't a whole lot of intervening steps. There aren't complicating factors like converting units on both the top and bottom of a ratio, or squared or cube units, which require some additional steps that we will get to in our later videos. So dimensional analysis is really a form of conversion. We have a measurement that's in a particular unit and we need it in a different unit for one reason or another, depending on what we're doing. So we use dimensional analysis in chemistry to take a certain measurement, a value, and change it from one unit to another without changing the actual value itself. We're expressing it in a different version, converting it or exchanging it. Now, let's take a look at something that would be pretty common. You do dimensional analysis all the time by converting between things that you don't really think about, and you just don't set them up in a formal way like we're going to do here. But I just want you to understand that this concept is something that we all do almost every day. Let's use a very common thing like pizza. Okay, so the question is going to be, how many slices are in 9 pizzas? Okay, now you may be able to work this out in your head if you're familiar with the number of slices per pizza and that sort of thing. But what I want to do is I want to set this up as a dimensional analysis problem so that you can see what we're doing isn't complicated. It's setting it up in a certain way, and then when we start dealing with other units that we use in chemistry that might be unfamiliar, you have this foundation of simple problem-solving steps regardless of whatever those units might be. And we'll get into some more complicated problems later on, but they'll all be based on these same first steps that we take. So what do we need in order to get from 9 pizzas to a certain number of slices? What we really need is what's called a conversion factor. A conversion factor is a ratio with equal values on top and bottom, but expressed in different units. We talked about this in the earlier video. In this case, what we need to know is how many slices are in a pizza. We need a unit that converts between those two, or a ratio that converts between those two. So typically, one large pizza has 8 slices. Okay, which means if I put a ratio together of 1 pizza over 8 slices, or 8 slices over 1 pizza, these two ratios are equal to 1, since 1 pizza and 8 slices are equal to each other. They're equal values, same amount of pizza, but just it's expressed in 2 different units. 1 unit is pizza, 1 unit is slices. It means the same amount of food at the end of the day. So now, in order to convert 9 pizzas to a certain number of slices, we're going to use one of these conversion factors. Which one do we pick? Well, what I always like to do is look at what I'm starting with. I'm given 9 pizzas. I want to get rid of the unit of pizzas because I want my answer to be in slices. So in order to get rid of that pizza unit, I need pizzas to be on the bottom of my conversion factor. So I'm going to use this conversion factor here. 1 pizza is on the bottom. 8 slices is on the top. Now the unit, pizzas, appears on the top here and on the bottom. And if you're struggling with the fact that this is on the top when there is no bottom, you can kind of keep in mind that this could be rewritten as 9 pizzas over 1. It would mean the same thing. Now we've got pizzas on the top and pizza on the bottom. Cancels out. The unit that's left is slices. I can't cancel that out because it doesn't appear anywhere else in this side of the equation. So what I've got is 9 times 8 slices over 1. 9 times 8 would be 72. So the answer here would be 72 slices of pizzas equals 9 pizza. So we've converted 9 pizzas to 72 slices. It's the same amount of food. we've just changed it from one unit to the other. That's what we call a one-step conversion, because I only needed one conversion factor. And I only needed that, because I had a factor that had the unit I started with and the unit I wanted to end with in one ratio. We'll take a look in a second at what that does when we don't have one conversion factor that includes both units. All right, let's take a look at a two-step conversion, and we're just going to extend our pizza analogy because why not? Pizza is awesome. So what if we wanted to know, if we have 10 people, how many pizzas do we need to order? Okay, now there isn't necessarily a direct conversion between people and pizzas, unless you assume that each person is going to eat some whole number of pizza, like 1 or 2 whole pizzas. But what we need an intermediate conversion that gets me from people to pizzas. We just need something in between. Well, remember that in our last problem, we said that 1 pizza equals 8 slices. Well, what if we said that each person, or each people, I'm going to write it people, I know that's not grammatically correct, but just to keep the units together, 1 people is going to eat 4 slices. Okay, you might say that sounds like a lot, you might say that doesn't sound like enough, but just bear with me. We're going to use that for this problem. Well, now I've got slices in 2 conversion factors. I've got people to slices and slices to pizzas, and so by going in a roundabout way here, I can get from pizza to people, or people to pizza. So again, we're going to start with what we were given. We were given 10 people, and we're going to multiply that. Well, we have a unit here that has people, an equality that has people in it. I'm going to turn that into a conversion factor, a ratio with equal values on the top and bottom. Which one goes on the top and which one goes on the bottom? Remember, the one that you start with, we want to cancel that unit out, so I have to put that unit on the bottom. So 1 people is 4 slices. Okay, so in this step, what I did is I converted people to slices. In the second step, this is why it's a 2-step problem, I'm going to convert slices to pizza. So I went people to slices, now I'm going slices to pizza. So how do I set that up? Well, since I have slices on the top here and I don't want slices in my answer, I have to put slices on the bottom. And I put pizza on the top. Okay, so 1 pizza equals 8 slices. And that's going to equal some number of pizzas. Now, I can cancel out the unit people, cancel out the unit slices. The unit that didn't cancel out was pizza, which is what I want my answer to be, so I've got that set up correctly. So I have 4 times 10 times 1 pizza over 1 times 8 with no unit on the bottom. So 10 times 4 would be 40, divided by 8 would be 5 pizzas. So I converted the people into pizzas in 2 steps. First by converting people to slices with the first conversion factor, then converting the slices to pizzas with the second conversion factor. So 2 steps necessary because I didn't have a single conversion factor with the starting and the ending unit in it. So I had to use that intermediate step of slices. Now let's take a look at a couple of problems using some more chemistry related units so you can get a feel for what these problems are going to look like in a chemistry class. So let's take a look at a 1-step conversion and then a 2-step conversion involving something we would do in chemistry all the time. So let's say I want to know, I have 63 grams of water, H2O, and I want to know how many moles of water is that? Don't worry right now if you don't know what moles means. It's a number like a dozen, just means a specific number of things. But that's not really the factor here. I'm going to show you how to solve this problem from grams to moles using dimensional analysis. And even if you don't know what that unit is, if you just bear with me, I'll show you how to set this up. Well, what I need to know is a conversion between grams and moles. Well, 1 mole of H2O equals 18 grams. Again, you might not know where I got that number. In fact, you probably don't at this point, but that's okay. That's another video for another day. Suffice to say that 18 grams of water equals 1 mole. Now I can set that up as a conversion factor and use it to solve my problem. 63 grams of water times conversion factor. Well, I'm starting with grams, and if you want to put that over 1, you can. Grams on the top, so I want grams on the bottom, and we said that 18 grams equals 1 mole. Now I've got the grams on the top and the grams on the bottom. They cancel out. What I'm left with is 63 times 1 mole over 18. So I have 63 over 18 moles, which simplifies to 3.5 moles of water. Okay, so 63 grams of water is equal to 3.5 moles. We've changed the unit here, but because we multiplied by a conversion factor that's equal to 1, we didn't change the value. It's the same amount of water expressed in 2 different units. And we do this all the time in chemistry. Converting from grams to moles and moles to grams is absolutely a foundational concept that you will need to understand in order to succeed in chemistry. And when you get to it, just remember, these are the steps that we're going to be using. But Dr. Ward, what about a 2-step problem that we would use in chemistry? I'm glad you asked. Let's take a look at 2.5 moles of aluminum, and we want to convert to find out how many milliliters of volume would 2.5 moles of aluminum occupy. Good question. There is no conversion from moles to milliliters. Not directly anyway, but we will get there by using a 2-step conversion. So we need a conversion that has moles in it and a conversion that has milliliters in it, and they have to share a common intermediate unit. So the unit that we're going to use is grams. We saw in the last problem that we can convert between moles and grams, and we can convert between grams and milliliters using the density of aluminum. Again, if you're not familiar with density, you will learn about that in chemistry as well. But for now, we need to know that 1 mole of aluminum equals 27 grams. That comes from the periodic table. So does the molar mass of water, which we talked about in the last problem. And notice that the number 27 grams is different from the number of grams in a mole of water. Different substances have different molar masses. You'll learn more about that in another video. So we have grams here, and then 1 milliliter of aluminum equals 2.7 grams. So I have a unit of grams with moles and a unit of grams with milliliters. So now I can use the unit of grams as the bridge between these 2 units by doing a 2-step conversion. We'll start with our 2.5 moles. Remember, we can put that over 1 just to be clear that we're putting stuff on the top and the bottom in different places. Since I want to cancel out moles, I have to put moles on the bottom. 1 moles, I know grammar, on the bottom is 27 grams on the top. Second conversion factor with grams and milliliters. Since I don't want grams in my answer, I have to put the 2.7 grams on the bottom and the 1 milliliter on the top. Whatever you're converting to in your answer should be on top of your conversion factor. Whatever you're converting to goes on top. So this is going to come out with milliliters because the moles are going to cancel each other out. The grams are going to cancel each other out. So what we're left with is 2.5 times 27 times 1 milliliter over 1 times 2.7 grams. So we get 67.5 over 2.7 milliliters, which simplifies to 25 milliliters. So 2.5 moles of aluminum would occupy 25 milliliters. We converted from moles to milliliters by using the unit of grams in between and doing a two-step dimensional analysis conversion. In the next video, we'll expand on this to problems that involve multiple steps beyond two, several steps, and also what happens if we need to convert units that appear on both the top and the bottom of our conversion factors. We'll do that in the next video.